Okay, welcome back everybody. This is the last video that we're going to do on the measuring of the magnetic field lab. The analysis part is the final stage, and then you'll have some questions that you'll have to answer on your sheet, and we'll talk more about that in class as a follow-up. Okay, so let's take a look at the analysis part. Okay, so I have provided you with this data on Blackboard. Okay, this is the data sheet that has the voltages that we measured from the pickup coil as a function of distance in centimeters from the center of the coil. And I've tabulated this in a spreadsheet here. Okay, so you can see here that the headings here is the Z in centimeters, and I have Z in meters. And then here is the millivolts tabulated here. And then, okay, and the first thing on the analysis was to set up a spreadsheet with VP versus Z, okay? And then we're going to convert the axial distances to meters, which we did here. And then we're going to convert millivolts to magnetic field, okay, by multiplying by your conversion factor, okay? This is a set of data that I took some time ago, okay, and my conversion factor was 4.88 times 10 to the minus 8 Tesla per millivolt. You'll get some other conversion factor that we did earlier today. So now you're going to calculate the magnetic field as a function of distance, okay, using just the formulas in your Excel spreadsheet. And then we're going to also calculate a theoretical curve, okay, and then we're going to overlay them and compare them and see how they look, okay. So the theoretical curve is basically given by this formula, okay, and this is in your lab sheet too, okay. We actually did this, okay, in class, okay, for a short solenoid. We derived that formula where R is the radius of the solenoid, N is the number of coils, I is the peak current, Z is the axial distance. Okay, so that is the magnetic field for any distance along the axes of the solenoid. And so I took a little shortcut here and let X be equal to the square root of this denominator right here. Okay, so I just took the square root of that denominator and set that equal to X, and then substituted it in there. So here you can calculate X as right here, the square root of that denominator is calculated right there from Z and R. Okay, Z squared plus R squared. Okay, let me write that down here. X is equal to the square root of Z squared plus R squared. Okay, Z squared plus R squared. So you're basically, now you're just going to plot the theoretical function there, and you can see our numbers are fairly close together as it is, okay? And then you're going to make a graph, okay? So here's what your graph should look like, okay? The blue dots are the experimental, and the red dots are the theoretical, okay? So you're basically going to plot two graphs on there. Z is the axial distance from the machine. You should do it in meters. I did it in centimeters, okay? But you can do it in meters, and you'll get a magnetic field there, okay? And then here, what you'll do is fit your, you can make another graph, or you can do this on the other one, okay? But you can make a graph of your experimental data, okay? And then what you will do, the data points are your experimental data, and what you're going to do is fit a power function to it, okay? So instead of fitting the best fit line, you go into Excel and you will basically display a power function, okay? Right here, step 5. Fit a power function to the graph and display the equation. Okay, so when you display the equation here, it will show up as a constant times e to the x to some power. Okay. Okay, so the power p is what you're interested in, and if you fit this function right here, okay, if this was x squared plus r squared was x, okay, I can draw that out for you here. Let me just draw this out for you. Okay, the B field is mu 0 I times n times r squared over 2 c squared plus r squared to the 3/2, which is equal to mu 0 I times n r squared over 2x cubed, okay, where in this case here x is just the square root of z squared plus r squared, okay? So this is basically what you graphed, okay? So if you graph this and fit so you're going to get a graph that kind of looks like this. BP as a function of x, okay? If you graph that function, okay, and fit a power curve to it, okay, so you basically are going to fit a power curve to it. The equation that you display is going to be basically y is equal to a times x to some power, okay, and p should be 3. P should be equal to minus 3 if you did it right, okay, so p should be equal to minus 3 if you did it right, okay. So that's the analysis part of the lab, okay. So basically, if r is small compared to z, then the B field should vary by 1 over the distance to the third power. Okay, so there you go. That ends the analysis, and the next part is some more advanced stuff, which has to do with the questions, and I think we'll cover that in the webinar. So send me an email or a course message if you have any issues with this lab, and we can get it straightened out for you.